What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-008 certification. So let's get into it. In this video, you're going to learn about additional monitoring tools such as syslog, logs, application logs, security logs, system logs, environmental monitors, interface statistics and statuses, and NetFlow. All right, so let's talk about additional monitoring tools. So network administrators routinely monitor network resources and review reports to be proactive in their administration. So for example, a potential network issue might be averted by spotting a trend such as increasing router CPU utilization or increasing bandwidth demand on a wide area network link. Monitoring resources and reports come from various sources such as a syslog server, an SNMP server, event viewer logs on Microsoft Windows Server, and packet captures from a network sniffer. Remember that monitoring is also critical in the area of network security. So for example, security information and event management are SIEM software products and services. They combine security information management and security event management. And this video is going to introduce a number of resources for monitoring network information. Now, an organization should consistently conduct log reviews, and a log review should include the following at a minimum. You need to have traffic logs. So you can use a variety of traffic logging mechanisms, many of which are built into devices. So for example, many devices today support what is called NetFlow, which is a powerful traffic monitoring tool that can export traffic flow information to a central collector on a network. Now, keep in mind that traffic logging vehicles differ based on the network environment. So for example, you might rely on NetFlow in an on-premises network. You might be using VPC flow logs in your AWS infrastructure as a service environment. And then you have what is called audit logs. So you might audit many actions in your network environment and record them in an audit log. So for example, a network device might have a setting to log each time an administrator logs into the system and uses admin power. These logs can be very valuable in tracking and monitoring the admin activities in your network. In AWS Cloud, this offers a tool called Cloud Trail that can log every activity that takes place in your public cloud environment. All right, so let's talk about syslog. So a variety of network components such as routers, switches, and servers, they can send their log information to a common syslog server. By having information from multiple devices in a common log and examining timestamps, network administrators can better correlate events occurring on one network device with events occurring on a different network device. And syslog messages and SNMP traps, they can be used to trigger notification messages that may be sent via email and SMS. And the syslog logging solution consists of two primary components. The first one you have is called a syslog server. So a syslog server, it receives and stores log messages sent from syslog clients. And then you have the syslog clients. So as you can see in this picture on your screen right here, various types of network devices can act as syslog clients and send logging information to a syslog server. Messages sent from a syslog client to a syslog server, they can vary in their severity levels. In this table listed on your screen right here, this lists the 8 severity levels of syslog messages. The higher the syslog level, the more detailed the logs. So keep in mind that more detailed logs require additional storage space on a syslog server. And this picture right here shows the format of a syslog message. And the syslog entries, they contain timestamps, which can help you understand how one log message relates to another. And the log entries also include severity level information in addition to the text of the syslog messages. All right, next let's talk about logs. So in addition to logs that are generated by routers, switches, and other infrastructure gear, the operating system powering network clients and servers generally have the capability to produce log output. Rather than containing general log information, such as log information about all of the system's track components, Microsoft Windows incorporates the Event Viewer application, which allows you to view various log types, including application, security, and system system logs. And these logs can be archived for later review and can be used to spot network trends and provide data for creating baselines. Now, as a side note, logs are beneficial in your network management endeavors only if they are reviewed. So be sure to document standard operating procedures for periodic and careful review of the many logs that are incorporated into your network. All right, next let's talk about application logs. So Microsoft Windows application logs, they contain information about software applications running on the underlying operating system. And in this picture on your screen right here, you can notice the 3 levels of severity associated with the events in the log. And they are information, warning, and error. The events provide a collection of information about the event, such as the source or the application that caused the event, the severity level of the event, and a date timestamp of that event. And this picture right here shows an example of a Microsoft Windows security log highlighting both successful and failed login attempts. And a Microsoft Windows system log, which you can see on your screen right here, this lists events generated by the underlying operating system. All right, next let's talk about environmental monitors. So components making up a computer network, such as routers, switches, and servers, are designed to operate within certain environmental limits. If the temperature rises too high in a server farm, for example, possibly because of an air conditioning outage, components could begin to fail. To prevent such an occurrence, you can use environmental monitors to send an alert if the temperature in the room rises above or drops below administratively configured thresholds, with the appropriate personnel being alerted about a suspicious temperature variation before it becomes an issue. Action can hopefully be taken to, for example, repairing an air conditioning unit or providing extra ventilation, thus preventing a system failure. In addition to monitoring a room's temperature, you can use environmental monitors to check a room's humidity. Also, environmental monitors, including power and temperature monitors, they can alert appropriate personnel in a variety of ways. So for example, as you learned earlier, some environmental monitors can send alerts to an SNMP server. This type of alert is known as an SNMP trap. Another common modification option allows an environmental monitor to send an email or SMS text message to alert appropriate personnel about the suspect environmental condition. And then you have fault-tolerant power options such as uninterruptible power supplies, fault tolerance power circuits into the building, generators, and appropriate converters or inverters for the critical network devices. These can assist in preventing downtime in the event of a single power failure. In monitoring systems, they allow you to react and provide redundancy. And devices should be placed in racks in such a way that air can properly flow through the systems in the racks. Racks may be 2 or 4 post racks organized into rows. You have freestanding racks. They can also be used to hold network systems and devices. A rack mounted server, this has rails on the side that allow it to be inserted into a rack. And environmental monitors, they can trigger alerts about potential damage if the humidity or temperature goes outside the values specified for network devices and servers. And environmental monitors and sensors, they can also be used to detect water and send alerts when water is present in a network closet or data center. Whether you had water on the floor due to flooding or water coming from the ceiling due to excessive rain or structural damage to the building, you will want to be alerted to this unwelcome element as quickly as possible. All right, next let's talk about interface statistics and status. So network device interfaces are a key component of a network environment. Fortunately, there are many mechanisms you can use to monitor these important components. You can monitor the various statistics these interfaces have to offer, and you can also obtain at-a-glance status information when you are troubleshooting problems in the network. And the following, these are just some of the statistics and statuses that you need to monitor. So you have what is called the link state. So this tells you if whether or not an interface is up or down or in some other status such as suspended. You got speed and duplex. This shows the speed and duplex settings of the interface. You have the send and receive traffic. So network devices, they can report on the amount of traffic sent and received. You have the CRC, or the cyclic redundancy checks. And CRC, this is a mathematical algorithm that is executed by each sender of packets. The network devices can compare the CRC values received and gather evidence that there was no corruption of the data in transit. And CRC errors, they are an important metric to watch out for. And then you have the protocol packet byte counts. So network interfaces, they can often report on the types of protocols for which they are sending traffic, as well as the number of packets per protocol type. And clearly, this information is very valuable when you are monitoring a network for baseline operation. Now, the following are the specific network interface errors and alerts that you should watch out for at a bare minimum. The first one is the CRC errors. So watch for these errors to ensure that your media is functioning properly and that you do not have attackers attempting to corrupt the data in transit. You have what is called giants. And giants, these are alerts that are reported when packets are larger than 1,500 bytes. In such packet sizes, they might be perfectly normal in your enterprise or data center environment. You have what is called a runt. So like giants, runts are alerts based on packet size. A runt is an Ethernet frame that is less than the IEEE 802.3's minimum length of 64 octets. And runts could be caused by collisions, malfunctioning network interface cards, buffer underruns, duplex mismatches, or other software issues. And then you have encapsulation errors. So perhaps an interface is configured for a PPP operation and you are connected to a device that is not enabled for PPP. This mismatch would prevent the interface from functioning, and the interface would be reported as a line protocol that is down. And then finally, let's talk about NetFlow. So Cisco introduced NetFlow to the world around 1996. And as previously discussed, NetFlow gives network administrators the ability to collect IP network traffic statistics as traffic exits or enters interfaces. By analyzing the data provided by NetFlow, you can learn all kinds of valuable information about how your network is actually being used. And NetFlow can also be a key tool for tracking down network bottlenecks, which tend to be somewhat inevitable. And by using the data collected by NetFlow, you can often quickly determine root causes. So a typical implementation of NetFlow includes the following. You have what is called the flow exporter, and this component aggregates packets into flows and exports flow records towards one or more flow collectors. Then you have the flow collector. This component is responsible for reception, storage, and pre-processing of flow data received from a flow exporter. Then you have the analysis application, and you use this application to analyze received flow data in various contexts. So perhaps you are most interested in performance issues during key times of the day, or perhaps you are more concerned about security issues that NetFlow might be able to help pinpoint. All right, so that was my video where we talked about additional monitoring tools such as syslog, logs, application logs, security logs, system logs, environmental monitors, interface statistics and statuses, and NetFlow.